Hey, hi everybody. How are you? So yeah, I'm Arthur, and I'm here today with Valentin. We are application engineers at Parity, and we will run these deep dives around the custom RPC and the runtime API of substrate nodes. So yeah, let's get started. So here's the agenda. The idea here is to cover RPC, and also then we will cover the runtime API, how we use it in Substrate. Then we will get an overview about best practice. And final, Valentin will run some demo about how to interact with this substrate node using RPCs methods and the runtime API. So yeah, let's get started. So RPC stands for like remote procedure calls, and it's basically a way that the node has to communicate with the external world, like receiving data inputs and responding with outputs of those requests. And it's basically by requesting or sending RPC methods, we can trigger an action that the node can perform, or we just can like read something for the node storage, or like the node current state or even a previous state. And the substrate node, in the substrate context, we use the JSON RPC. So it's basically like you need to send a JSON data, like the object itself, and you will for sure receive a response back in a JSON format too. So yeah, and the most convenient and common way to interact with this is by using the Polka.js library API that we will see in a few. So yeah, this is like a diagram, a very simple overview. So we have this actor here that can be like a front end application, a backend service, or even a regular user that is, oh, I want to check for my balance, or I want to send an extrinsic to change the runtime state. So this can be performed by sending this RPC request directly to this RPC server that is running in the client part of the substrate node. So yeah, and we have this all this service, the transaction pool, the networking, and the storage, and all the logic of our runtime, the WASM itself there. So it's the way to communicate with this external actors. And yeah, so here we put a simple example. So just like using JavaScript Axios, the very common HTTP library to use HTTP protocol. So here I'm sending a post request and using this system account next index as the method. We have the version of JSON RPC here, and also we need to put the parameters that we need to that we need to fetch data from for. And a heads up that we have this header, and we are really using JSON here. So what this method does is just like getting the nonce or index of this account ID, and this is Alice for our node template when we use the dash dash dev for running our chain. And here, as you can see, I'm just like logging the response data, and we are getting in the result field the 5, so the current nonce index of Alice for that chain in that on that state was 5. And here I'm directly just using CURL, the curl tool, simple tool, and I'm doing exactly the same thing. I'm setting the header, sending this data raw payload, exactly the same thing. And I'm using JQ here. It's another simple tool to just pre-print the JSON object here. the JSON data, and it's the same data. So yeah, it's the two way to interact with the like RPC client here requesting data, and the node has the RPC server is just responding with the data, responding back with data. And yeah, so getting like we can use Polka.js UI to like interact with the RPC server too. So we have this developer tab, and then we have RPC calls. We have this RPC subset of RPC methods where we have these methods, and it's a list of all available and exposed methods that our node is running, has implemented. So we also, for this first select box, we have this subset of multiple scopes to interact. So in every and each of these one, we have specific RPC methods to query or to send data to interact with. And yeah, so we decided to pick this first one. It's very useful. It's we can find it inside at alter subset and the pending. It's called pending extrinsics, and it's just like the transaction pool and what is there, like being ready to be included in a next block. So I sent an extrinsic in one tab of my browser, and then I submit this call here. And what I got here was that someone is like using the frame system palette, and it's calling the remark with this test string as a data for this remark extrinsic. And as you can see here, we have the signature too, and also who is the signer. So again, I was using just Alice, and we have the error here. It's not that important now, but it's like time to live of this extrinsic. Okay, so another interesting thing that we can in this other tab, I'm again using Alice to send a system remark um, extrinsic, but this time I'm not submitting the extrinsic, so I'm just like signing the extrinsic with the nonce and the lifetime, the error here. So what I got from Polka.js is this signed transaction. So it's a bunch of hexadecimals, but it's at the end of the day bytes there. So what I would do with that is like copy these exabytes, hexadecimals, and using now the author submit extrinsic with this huge data, like the signed transaction, and then I just click submit RPC calls, and what the node respond back was this hash is exactly the transaction hash. So it was indeed the node got my extrinsic, and it will be processed. So that's it. Oh yeah, so here I'm using my IDE to kind of list all the RPC methods that we have in Substrate code base. So what I did was just like filtering for this string method name equal, and my IDE was able to find like 79 methods. So as you can see here, we have a bunch of, in all those like subsets of chain, the author that we just demoed, and also the state. And we decided to highlight this one because this one is the state call. And as we can see on its description here, it's a way to call a method from the Runtime API at a block state. So you can like send a few parameters here that we'll cover in a bit. But this one will just create a connection between an RPC entry and the runtime. So yeah, here again using Polka.js UI, I'm using state call. So what I'm using, I'm populating things here. The method is the account nonce API, and inside that API we have the account nonce. So again, I'm using Alice, and I'm just submitting the RPC call. And yeah, the node responded with this bytes. And as we all know, it's scale encoded, and the scale is little endian, like WASM is. So we have to like transform this, and yeah, it's 5, the current nonce for Alice. And yeah, we can also fetch, as you can see here, I did not put anything on the at, so there's no block hash that I want to fetch the account nonce for Alice. So it will fall back to the latest block. So, but we can also set a block hash here, and this way the node will fetch the nonce for Alice from a previous state, from a previous block state, and it was 0, 1, and yeah, 1. Okay, so but from where the account nonce API are coming from. So this is exactly the second part of our deep dive today is the runtime API. So we have the substrate node with the services, the networking, all the logic, the transaction pool, and then inside it we have the runtime, our WASM, the runtime context, and doing all the logic of our palettes of our blockchain. And the runtime API is exactly this application programming interface, but that is a way that the client is able to communicate with the runtime, the WASM part of our solution. So we can do many things like reading, writing data to and from and to the runtime, the state, and also performing like state transition by sending extrinsics. And yeah, so by default, the node template substrate implement all these traits for the runtime. So we decided to select this tree as like like examples. So we have the account nonce API, the block builder now, and also the transaction payment API. So we pasted here. Let's go to read. We have we have the account nonce API, the trait itself, and it's been implemented for the runtime. And as you can see here, we have this inner account nonce inside the account nonce API. So there is this is the method, and this is the trait, and this is the method that we were calling back then. And then, yeah, here is the block builder that we will show in a few. And the transaction payment API, same thing. So all of them, of course, are being implemented for the runtime, the node template runtime. And yeah, so this time I decided to call the transaction payment API, query info, and here we have a bunch of hexadecimals again. And as you can see here, the transaction payment API query info, we have the UXT, an extrinsic, but we also have the length of that extrinsic. So we need to concatenate the both things in order to be able to really send the data, and the node will then like split them into these parameters using scale. And yeah, what we'll get here is this a bunch of bytes here. And yeah, but this time it's not that trivial to like decode by just looking at it. So maybe it should be a way to better parse and understanding this. And of course, indeed we have it. And yeah, so I'm using the Polka.js library here. And yeah, it's a very basic example. It's not like just copy and pasting, but just an overview. We are like instantiating an API here using WebSockets for directly connect to our node. And here I just paste that extrinsic bytes. And the cool thing around the API from Polka.js is that we have this call method from the API, and inside the call we have all the available runtime APIs, and of course the traits, and then its methods. And that's so cool because once you get it using VS Code or another IDE, it's able to autocomplete things for you. It's able to give you some hints about the parameters. So okay, this one is just one parameter. This one also one parameter, but this one is two. So you need to send an hexadecimals, but also its length. And that's so cool because we also, in order to get the data, we will have that scale data here, the bytes, but then we can parse it using this to human function that will give us a very useful and human readable information. So yeah, that's it. So the state call that we got before is just being transformed in this very useful data so we can use in our D app, the front end, or mobile application, or just our backend service. And it's way, way better to deal with this kind of data and not just bytes. Okay, so the last thing, and very important, is this trait metadata that we implement, that the node template also implements for its runtime, and it has this inner the method metadata. And what the magic here is that this is the metadata for the current runtime. So this is the guy that will tell Polkadot.js how to parse, how to decode these bytes into this useful information. So the metadata has all the palettes, all its extrinsics, all the typings, all the types involved in the outputs and the inputs. So that's pretty cool because once we have this, I don't know, maybe an example, we have our node has this RPC method that we call it method one, and for some reason, we decided to change it, the RPC method, to method two. So we will need to, of course, do the change in the Rust code, but then we will need to rebuild our node client, get this new binary, communicate to everybody, all the nodes of our network to, hey guys, everybody, please update your binary because we have this new RPC method, and if you don't do that, your node will not be able to respond to that method. And yeah, but if we decided to go to the runtime API like approach, we can change things like I don't know, maybe you can add a method here for the transaction, this trait, and then we implemented it here. And what this will do, by doing just a runtime upgrade, that will add or change the method name inside the runtime API trait, we will tell the runtime upgrade, we will also upgrade its metadata. So the metadata will get this change on the fly as soon as the runtime got is approved and it start to run in our chain. So that way, Polkadot.js will be able seamlessly to fetch this new metadata from that block onwards and start deal with this change. Like, oh, the method is not method one, but it's method two now. That's no issue here, no binary involved, nothing to do. Just the auto-completion will be able to parse that new metadata and tells you, oh, there is no more method one. It's now called method two. You can like inspect all the available methods and its types. So that's very, very powerful. And yeah, so just to like close this thing, we put some best practice here. So in order to create a very healthy network, uh, what we see is like it's not like very smart to have RPC methods that spend seconds and like minutes to respond. So there's no it makes no sense to really process a huge amount of data in just one RPC call. requests. So by doing that, you will definitely slow down your network, maybe even slow down your block production. So one thing is very like important to be aware is that validators, that kind of special nodes that really validate and produce new blocks, they should avoid to be exposed their RPC server, and that's the main point, because you should focus your validator resource like CPU, memory, the disk usage, just to process extrinsics, to analyze the state and also produce blocks, and not like handling this. What is the account the nonce for Alice account ID? Because it makes no sense to spend the resource with that. So it's a cool to think about this network architecture where you have the validators in kind of an inner circle, and then we have these other types of nodes that are not validating at all, but they can be like access nodes where you just receive this extrinsic from the outer world, and the extrinsics go to this inner circle of validators. But this first access node will really do the heavy load of processing this RPC request, like isolating the rest of the validators. And this is cool because we have index nodes. There is a huge nodes and archive nodes that keep a huge amount of disk space being requesting by using block explorers. And yeah, so just imagine when we are like using a block explorer, sometimes we want to fetch a very old data, and it can take seconds and maybe like then break for some reason, and then we just try to refresh or ask for that data again. That's fine for an archive node, because maybe we are fetching data from 1 year ago, 2 years ago, and that's fine because the user can handle that. But what we can like not handle is a validator spending like seconds and seconds to process, to go 1 2 years back and fetching data from there in order, and like not validating blocks. So that's very important to always keep that in mind. And yeah, so now Valentin will go ahead and kind of really sum these things in action by doing a demo and also a code walk. So
Hello, everyone. Thanks, Arthur. Hey, I'm Valentin Fernandez. I'm an application engineer, also like Arthur here at Parity. I will be going over a few ways to implement RPCs and how to make them interact with runtime APIs, and how do we interact with them from the outside world. So the idea is to go from something basic, simple, and then go to something more complex as we go. So the first thing we're going to do is implement an RPC without any interaction with the runtime. Just implement an RPC that gives us some data, maybe some data from a client or just a simple response, to see how this looks inside the code. So going to the code, here we have a substrate node template. And the idea is, as I told you, to just implement a simple RPC. So this RPC is going to be inside the client. So what we have to do is, let's do this like this. And what we have to do is go to the node. And in here, we'll see a file called RPC. And here's where the RPCs get instantiated, okay? I will show you a bit more of this code later, but first I want to go into this part right here. The idea is to implement a really simple RPC. So we have this trait that we implemented called silly RPC, and we will do just two simple methods. First, one that's called silly get 5. Anytime we call it, we will get a value 5. And then to do something more interesting that interacts with the actual client, we have this isBlock finalized that we can pass any value of a block and check if this block has been finalized yet or not. So how do we do this? First, we create this trait with the functions, and you'll see that it has a few interesting things. First, each function has this method macro. And this is really important to declare because this is the way we are going to interact with the RPC from the outside. So the name that we give to this function is the name that we will use afterwards to call this RPC from the outside world. So in this case, to call this silly get5, we will use this silly underscore get5. And for the other one, we will use silly isBlock finalized. Then we also have this macro RPC that I'll show you a bit more in depth in a few minutes. But first, I want to show you a few more things. First, of course, we're defining a trait, so we need a struct to implement this trait. So we have this silly struct, and you'll see that it has this generic C that is used to use the client right here. So if we were not using the client at all, like in this method silly get5 that doesn't need any info from the client, this could be left empty. But since we need to use some data from the client, we'll keep it using this. Also, we have this constructor with new, so we can define the silly struct. And then we have this implementation of the trait silly RPC. Now, you'll see that it's not silly RPC, it's rather silly RPC server. Now, where did this come from? Because we defined here a silly RPC. Now, this silly RPC server, and if we look a bit more here, we'll see that it's silly RPC server and client. These two appear thanks to the fact that we declare this RPC macro. This macro will create, based on this information right here, we'll create two traits, one for the client and one for the server, then we can use to then implement the functions and add it to our RPC module. So if we look close here on the data that this RPC provides, let's see if it loads. It's not loading, but anyways, what this will do, what it generally says in this description is that this will create, based on this data, a new trait. There we go, we can read it. For servers, it would generate a trait mostly equivalent to the input, so mostly equivalent to the trait we defined. But if we look here, it says that we'll have one additional method into RPC, which will turn any object that implements the server into an RPC module. This is important because we need this RPC module. Now, in here, we'll define the way the function is going to work. So silly get5 just gives us 5, and this isBlock finalized, which is a bit more interesting. It says that .client, so our node client, and we want to get some info. This function will give us, for example, the best hash, the finalized number, the genesis hash. So we can use it to get the finalized number, compare it to the one we pass, and check if the block has been finalized or not. Okay, so going back a little bit, what we've done is define a trait with its macro definition, so the method and the RPC, define a struct so we can implement this trait, and then in the trait implementation, define how the functions will behave. The last thing we have to do is go back to here, to this function, create full, that if you read the description, it says that it will instantiate all full RPC extensions. So this will help us, as it says, start instantiate the extensions we need. For at default, we have the system and transaction payment RPC extensions. But in our case, we want to instantiate the silly RPC server. So we'll do silly RPC server into RPC and passing the struct. With this, we already have the RPC implemented. Now to show you that this works, we'll run a node and see how this interacts with the chain. So I already have it compiled here on this old RPC. So I will start the node. Let me change this here. the node starts. And okay, the first thing we're going to do is go to polka.js and see if it's working. So see if we can connect. So if something else is running, should be able to connect. Let's see, node, try switching. See if this fixes it. It's not. Let's run it again, just in case. Let's do this. Let's see if this fixes it. Okay, there we go. So first up, let's see if these RPCs are indeed inside our implementation. So for this, we'll do RPC methods. And this gives us all the methods we have available. And in here, we can see that silly get5 and silly is block finalized are included, so we can use them. How do we use them? We have a few options. First, we can do a simple curl request. So calling the HTTP, so calling the node at 9944. We're calling the method silly get5. And if we call this, we get 5. Now, this is not really comfortable to interact with. Another way to do it is we can use Postman, for example. Here I have the same request. So localhost 9944, method silly get5. Then we send it and we get 5. Great. And now if we want to check, for example, the silly is block finalized. Let's see, for example, let's check if the block 30 is finalized. We get that it's not. If we go to the network, the last finalized is 11. So let's check, for example, block 10. And indeed, we get true. So we can check some data on the client just using these functions. Now, this is good, but what happens if we need some data from the runtime? This is where the Runtime APIs come into play. So we are going to go back to the slides. And in here, now we want to add an interaction to the runtime. Using this, we want to implement a Runtime API that serves as an interface between our runtime and the outside world. So going back to the code, how do we implement this? The simplest way to do it is to implement a few functions here. So anyone that is that has worked with the substrate node template is probably familiar with this valid template. For anyone that hasn't looked at it, all we need to know is that it has this function, do something. This function, we pass any value, and then it stores it in a database, nothing else. And we will use this one to showcase how to interact with the runtime. I defined two functions here. We have sum5 and sum and store. Sum5, basically anything that's on storage on this something key, just sum5 and give me the result. And sum and store, we pass a value and get the value from storage, sum it, put it back on storage, and then give me the result. So for example, if there was 10 on the storage and I pass 5, it would do 10 plus 5, put it on the database, and then give us the result. Just to show you really quick how this extrinsic works, we can do something. Let's store 10. This will run for a few seconds. And if we check on something, we have 10. OK, now we want to create an RPC for this. The way to do this is, first, we need to declare a trait for this. So if we go back to the palette, again, I have this new folder called RPC. In here, I have this Runtime API. And here you'll see that there's a trait defined. This trait has the functions that I want to expose. So I have sum5 and sum and store. And all of this trait is wrapped in these declare runtime APIs. Now, what does this macro do? We can go to the docs and read exactly what this does. It will be pretty clear here. So it says that this macro will create two declarations, one for the client side and one for the runtime side. And that the client side declaration will get self and at. Add is the one that we care the most about because it will allow us to pass this extra parameter that allows us to query the state at the block that we pass. So we can do the current block, block 100, 200. So we define this trait, and the next thing we have to do is implement it. The way we do this is we go to the runtime that will implement this trait. And in here, in the file where we define all the palettes we use, probably if you work with Substrate, you've seen these implement runtime APIs. And in here, we implement all the runtime APIs. So we can go down to here, and we will see that we are implemented this palette template runtime API, which is this thing that we had here. And it has template API with a generic block. Now, where did this block come from? Thanks to the fact that we wrapped it here, it added this extra generic to the declaration. And here we can define the way we interact with this. So basically, sum5 just calls sum5 in the template module. Sum and store just call the function sum and store. Pretty simple. Now, we have defined on the runtime all the APIs that we need to interact with. Now we need to define on the client how to interact. So if we go back to the palette template on our RPC folder, we also have this file that is really similar to what we did before on the client. So you'll see that we have this template API wrapped in RPC, and then the methods with the name template sum and template sum and store. So really similar to what we did in the RPC file with this. Also, we have the constructor and then the definition of the struct and the constructor. And then we have the template API server where we define the implementation of each method. Now, I want to take a close look on how this was implemented, because remember I told you that with this declare runtime API, the client side gets an extra parameter called at. So if we go to here, we define this at, which is a block hash. And then, for example, in this function sum5, we get this at value. If there was a value, we get it. Else, we get the best hash. So we get the latest block. And then we have to call the function that we do self.client.runtime API. And we'll see that in this .runtime API, we have now this .sum5. This function is now available to us thanks to the fact that we declared it here on the runtime. So thanks to the fact that we did this, now we can call this function in the client side, passing the at parameter, and in the sum and store, passing at and a value. Okay, so we have the declarations on the runtime side. We have the declaration for the client side. The last thing we have to do is, like we did with the silly RPC, go to this create full and instantiate the template API server. This way, now it's already available to us. If we want to check how this works, we can go to this, for example, this template sum5. And remember, we stored 10 on the database before here. So this should give us 15. So we go here, 15. And sum and store, let's say that to that 10, we want to sum 30. So we would get 40. We call it and we get 40. So both functions are working. Another way we can call them is using state call. As Arthur showed you, we don't need to call the RPC directly, but we can call the runtime API instead. So we do this state call to template API, which is the module, and then sum5, which is the function. So to show this in a more simple way to understand, we have the module template API, so template API, and we have sum5, sum5. And we call it, and we get the result, but in this case, we get it in scale encoding. Now, the Last thing I want to show you is something that is really interesting with this function sum and store. To remember what this was doing was storing something in the database and then giving us the result after summing the values, right? Now, of course, we did this sum before. So we did 10 plus 30 and we got 40, which was the result stored on the database. So in theory, now the database should have 40, right? And if I do now plus 5, we should get 45. Thing is, we don't get 45, we got 15. So what's going on here? And if we do, again, let's do 20, it should be 20 plus 15, but we only get 30, and it should be 35. So what's going on? Even if we go to this template module and we query again, the value is still 10, even though we are explicitly telling in this function that we should be storing on the database. So to understand what exactly is going on here, we have to look a little bit more in depth on how runtime APIs work, runtime APIs and RPC calls work. First of all, to remember, let's go back to how a transaction works. A transaction, we send a transaction to a node. In this case, do something to store a value 10. Currently, the state is 5, and this, what it will do is it's going to gossip this transaction to all the nodes, avoiding extra complexities, like it needs to be validated, included in the block. But the base idea is that after it's included in the block, everyone will have this same notion of what the state of the network is, right? So this value for everyone should be 10 after this transaction was executed. Now, what happens when we do it via an RPC call? In this case, the RPC call gets sent to this node again, so store something. But in this situation, the RPC call is only viewed by this node. All the rest of the network doesn't even know that this RPC call even happened. They are not aware of it. So what ends up happening is that if we want to store something in this function, the execution will mock the database, will execute, but the state of the actual database won't be changed. And this is for the very simple reason that if this were to be changed, then we would see that this node would have 10 and the rest of the network would have 5 in this value, which would be a problem because this node would disagree with the rest of the network, saying, oh, I got the value 10 and everyone has 5, so they would think this node is lying. Therefore, there would be a problem with consensus with this node. Okay, I think that's all we have for today, but we are open for questions now.
Are there any examples using REST frontends to access the API? I'm not aware of directly example of a REST crate that can do that, but by using state call, the RPC method, it should be very like straightforward. Maybe using even Hyper, the REST library. But I can also we have the subxt tool that is using this JSON RPC library from Parity, both tools, the library and the tool, and that can give you a guidance about how to interact with that. But like I said, it's just like sending JSON data and waiting for the node to respond back with JSON data. So it should be very straightforward to implement that on your front end. Maybe if I paste the links. Okay, so So I'm not sure if it. No, I think I'm on the. Yeah, who is sharing? Is it me?
I'm currently sharing. There we go.
Okay. Okay. Maybe if we change for my screen,
The
or you can just open the subextra repo just to.
I think that's your screen now.
Oh, okay. So yeah, this is the tool that I mentioned. The subxt is like submit extrinsics to the node via RPC, and we also need.
Arthur, I think you're only sharing the slides.
Oh, okay. I'm sorry about that. So what about? um, is that working? Okay. Yeah, I
Yeah.
think so. Yeah, so this is the subxt. It's under partytech org on GitHub. And yeah, so it's like how to submit extrinsics to a node via RPC. And yeah, so it's just Rust. And we also have if we send here, this is under parity tag again. We have the JSON RPC. This is the library that the substrate node, we use it everywhere just to implement those traits, the macros. All of them just comes from this library. So we have a bunch of examples here, so it should be like cool to take a look on this and how to use it. And yeah, but directly like we have Polka.js UI doing all that magic for you. I'm not aware of a Rust thing for front end. Cool. Do we have more? Yeah, I think I can. Yeah, maybe we should share the your node template change,
Oh
Valentin.
yeah, sure. I don't have it currently on a repo, but I can upload it in a few minutes
Cool.
and post it in the chat.
Yeah, this recording will be available soon
Yeah.
on YouTube, so we can paste on its description. Yeah,
Yeah, I think I can do that.
nice. So let me check the chat. Yeah, we can use a small doc too. Thank you. Cool. Nice. So written tutorial. Yeah, we will share the links on the recording description. Roger, thanks. Cool. So yeah, I think that's it. We are on time. So thank you guys. Yeah, well, I hope that we gave you some ammunition to implement and improve your substrate nodes by exploring and like playing around with Runtime API. That's really amazing. So yeah, go for it and feel free to open issues, ask questions on our substrate Stack Exchange and Polkadot forums. Yeah, we are here to help you. And yeah, that's it. Thanks.
Thanks everyone.
Bye. See you.